Hello, year sevens. I hope that you're well and that you're in a quiet place away from all distractions. In today's lesson, we're going to be learning about electrical current in a circuit. Our first task is to complete our retrieval practice questions. Match the symbols of electrical components to their label. Please pause the recording and do this now. You may have noted that the lamp is a circle with an X in it. The open switch, shows that there is no connection, so electricity will not pass. We've got cell with a long line and a thicker, shorter line, and a battery, which basically is two cells. We've got the resistor here, which is a rectangle. We've got the ammeter, which is a circle with an A. The closed switch is the opposite of the open switch, which will allow electricity to pass. We've got the variable resistor, which is a rectangle with an arrow going through. The voltmeter, a circle with a V, and a moto, which is a circle with an M. So, our success criteria is to state the definition of current, to know the relationship between current, charge, and time, to calculate current, charge, or time when given any two of the other terms. So we talked about the ammeter in our retrieval practice. Ammeters measure the current through the circuits in amps, and that is usually a capital A. It is connected in series with a component, so the current through them is the same as in the example in the picture. So we can see that the electrons are passing along the wire and there will be both positive and negative charges. So the electric current is the rate of flow of charge in a wire or component. When the battery is connected, the electrons in all parts of the wires within the circuit move at the same time, in the same direction, and at the same rate. This movement constitutes the current. In this way, no matter where the components are in the circuit, they will all conduct at the same time. There is no delay because all the electrons in the circuit move simultaneously. That would be an example of a 2-mark question where you're asked to explain why current is not used up in a circuit. Pause the video and make a note of this now. Current is the rate of flow of charge. This is the amount of charge flowing past a point per second. How can you turn this into an equation? Current is equal to charge over time. As we've said before, current is the rate of flow of charge. Match the statements about electric current on the left, which are the colored ones, with the plain ones on the right, as a quick progress check. Pause the video and do this now. You may have noted that an electric circuit is a complete loop of wire where there's no interruption, no gaps. 2 or more cells joined together, they're known as battery. No current flows in this type of circuit. That's a circuit with a gap in it. The unit of electric current is the ampere, usually shortened to amp, and the flow of electrons around the circuit is known as the electric current. So current is the rate of flow of charge. This is the amount of charge flowing per second, like we've said. And our equation would be I is equal to Q over T. I represents current in amps, which is a capital A. Q would represent charge in coulombs, which is a C. And T equals time in seconds, which would be an S. So what is the current when 5 coulombs of charge pass a point in 2 seconds? Pause the video and attempt to do this question now. Q would be 5C. Time would be 2 seconds. Put that into our equation. I equals Q divided by T. That would be 5 divided by 2 would be equal to 2.5. We always write our formula, then we write our working out, and then we write our answer in order to get full marks. And we always write our units. So let's have a look at another one. Calculate the current flowing through the air in a lightning strike if a charge of 300 C flows in 0.01 seconds. Have a go at doing that. So Q is equals to 300C. T is equals to 0.01 seconds. I equals Q divided by T. That's our formula. I would be 300 divided by 0.01, and that would give us 30,000 amps. Okay, always remember our formula, always remember your working out, always remember to put your answer and your unit. How about this one? Calculate the charge flowing in 2 minutes for a toy that uses a current of 14 milliamps. So T is equals to 2 minutes, which we have to convert into seconds. That's 120 seconds. I would be 14 milliamps, which would be the equivalent of 0.014. And that would give us a working out, which would be Q this time, which would be equal to I times T, because we have to rearrange our formula. And Q is equals to 0.014 times 120, and that would give us 1.7 C, 1.7 coulombs. We've got our formula again, we've got our working out, and now we've got an answer and our unit. How about you having a go at responding to these questions? Pause the video and do these now. So, what is the formula for current? Charge divided by time. What are the units for charge? Coulombs, which would be a C. What are the units for current? Ampere, which would be an A. And what are the units for time? That would be seconds. Now, let's have a go at doing these questions. Please take your time and give yourself around 2 minutes per question. So, I formula for the first one would be I equals Q over T. Current would be 13. So we've got what is current is what we're trying to work out. So that would be 30 divided by 3. Our answer would be 10, and the units would be amps. Next one, what is current if 20 C of charge pass a point in 4 seconds? Our formula is I equals Q divided by T again. Our numbers in the formula would be 20 divided by 4. Our answer this time would be 5, and our units would be amps again. Next one, we're calculating the charge. So Q is equals to I times T. And then we've got our numbers now, which would be 10 times 30, and that's going to give us 300 C. How much time will it take for 50 C of charge to pass a point of if the current is 5A? So in the next equation, we're looking for time. So time is Q divided by I, and that would be 50 divided by 5. That would be 10, and that would be in seconds. Last one is current again. So what is current if 200 C of charge pass a point in 2 minutes? We've got I equals Q divided by T. We've got 200 divided by 120, and that's going to give us 1.7, and our units would be amp. Please pause the recording and green pen your work. Well done, year 7. We've come to the end of the recording.